One-step equations require one step to isolate the variable when solving an equation. That one step is either to add, subtract, multiply, or divide. For your 100 equation unit, test number 1 has 10 questions. They are all one step, and they can be solved by either adding or subtracting. Test number 2 also has 10 one-step equations. All of the equations can be solved by either multiplying or dividing. And test number 3 has 10 one-step equations, and those are a mixture of adding, subtracting, multiplying, and dividing. So to review, your first 3 tests each have 10 questions for a total of 30 points, and all of those equations are one-step equations. This is where you want to make sure and pay attention to details so that you don't miss out on these easy 30 points. To prepare you for the first 3 tests on one-step equations, I'm going to go through some examples. We talked about this in class where one-step equations can be done mentally, but when you start putting in negatives and fractions, it's probably best just to show your work and take a couple extra seconds to show that operation so that you don't make simple errors. So for the first problem here, in order to isolate the variable v, we are going to do the opposite operation of subtracting 15 and add 15. When we add 15 to a negative 27, we get negative 12. On this example, in order to isolate the variable n, we are going to get rid of that negative 15 by adding it to both sides of the equal sign. Negative 9 plus 15 is a positive 6. N equals 6. On the next problem, again, you could probably do this mentally, but showing that step of adding 6 takes just a couple of seconds, and we get negative 5 plus 6, which is 1. And finally, in order to isolate the variable w, we are going to add 9 to both sides of the equal sign to get w equals 13, but it's a negative 13 because there are more negatives than positives. All 4 of these examples require subtraction to isolate the variable. Again, they can be done mentally, but it takes all of 2 seconds to write down the operation to show that it's minus 12 to isolate the variable n. In this case, 4 minus 12 is negative 8. This next one's kind of tricky because it's minus a negative 16, so that's actually x plus 16. And so in order to isolate the variable x, we're going to have to subtract 16 from both sides, and then we get x is equal to 28. On this next one, if we subtract 4 from both sides, a common wrong answer is m equals negative 8, but what we want to make sure and do is when we have negative 12 take away 4 more, we're going to add those together to be a total of negative 16. So again, showing that step and so that you don't lose track of the negative signs will hopefully help you not make those simple errors. Finally, on this last example, in order to isolate the variable p, we're going to subtract 3 from both sides of the equal sign, leaving p equals 5. Next, we have 4 equations that require multiplication. So for this first example, I can isolate the variable v by multiplying by 3 over 1. That cancels out the 3's on the left-hand side, and when I multiply by 3 on the right-hand side, I get v is equal to negative 33. And something I don't always do, but I should, is double check my answer by plugging it back into the original equation. Negative 33 divided by 3 is negative 11. This next example right here could technically be considered a 2-step equation because there is that negative sign right here with the variable, I'm going to choose to put that negative sign with the 4 and then multiply by -4 in order to get rid of the 4 and the negative sign. So I can write negative u over 4 that way, or negative u over 4 this way. I can even write it as u over -4. The only way I can't write it is negative u over -4, because that turns into a positive u over 4. So when I multiply by -4 on both sides of the equal sign, I get -56 is equal to u. I'm going to go ahead and do this problem one more way to show you that you could do it a different way. So if I had 14 is equal to negative u over 4, the first step could be to multiply by 4. Multiply by 4. I get 56 is equal to negative u. In order to get rid of that negative sign, because I don't want to know what a negative variable equals, I want a positive, I can divide by -1 and get the same answer, u equals -56. We can double check that by plugging it back into the original equation. A negative 56 is a positive 56, and 56 divided by 4 is 14. Back over here to the example, 1/8 y is equal to -12. I can divide by 1/8, but as we know with fractions, when we divide, we actually multiply by the reciprocal. So instead of showing my work that way, I'm just going to multiply by 8 over 1 so that I can cancel that out and isolate the variable y, as long as I multiply by 8 over 1 on the other side of the equal sign to get my answer. So we have 96, and it's -96 because it's -12 times 8. And lastly, again, this could probably be considered a two-step equation, because I could multiply by 3 first, multiply by 3, and get -5x equals 60. Then divide by -5, divide by -5 to get my answer of x equals -12. But I will show you how to do this problem in one step by rewriting it over here. -5/3 x equals 20. I'm not going to divide by -5/3 this way, because when you divide fractions, you're actually multiplying by the reciprocal. So in this case, 3 over -5 cancels out the 5s and the 3s, and of course a negative times a negative is a positive. As long as I multiply by 3 over -5 on the other side of the equal sign, I can do some canceling here, and even if I don't cancel, I could get x equals 60 over -5. But if I do cancel, I'm left with 4 times 3, which is 12, and then a -1 in the denominator. So the answer is -12. Finally, these 4 equations all require division to isolate the variable. They can be done mentally, but again, to show the extra step of dividing by 15 takes all but a couple of seconds. In order to isolate the n, we take 15 divided by 15, which is 1, and then -30 divided by 15 is -2. A common wrong answer I see on this next problem is to add 7 to both sides, but that is not correct, because what's happening between the -7 and the t is multiplication. So the opposite operation is to divide by -7. -7 divided by -7 is 1, and so we've isolated the t, and then 49 divided by -7 is -7. Again, we can plug that into the original equation. -7 times -7 is a positive 49. On the next example, it's similar to one I showed on the previous slide, where in order to isolate the x, we're going to divide by 9/5. But when we divide by 9/5, we're actually multiplying by the reciprocal, which is 5/9. So I'm going to multiply by 5 over 9 so I can cancel those out. And when I multiply by 5 over 9, I can take 5 times 45, negative 45, and then 9 times 1, and then reduce. But I'm going to reduce beforehand by saying 9 into 9 is 1, and 9 into negative 45 is negative 5 times. So 5 times negative 5 is a negative 25 for x. Lastly, in order to isolate the k, we're going to divide by negative 5, and a negative divided by a negative is a positive. So in this case, k is equal to 25. One-step equations require one step to isolate the variable when solving the equation. That one step is either to add, subtract, multiply, or divide. Good luck on your first 3 tests on one-step equations.